Hey guys, welcome back. How are you? I hope you are good and doing well. In the last lecture, we implemented the selection sort in Ruby and discussed about this simple and basic sorting technique. Now, in this lecture, we need to move into something new. You can say a complex sorting algorithm, which is quicksort. Okay, but before actually discussing the quicksort, we first need to understand the principle on which quicksort relies and what. Okay, and the principle is known as the divide and conquer. Okay, so divide and conquer is an algorithmic approach and it is a powerful design paradigm used to solve complex problems by breaking them into smaller and more manageable subproblems. Okay, these subproblems are solved independently and their solutions are combined to produce the final solution. This approach particularly effective for problems that can be naturally divided into similar subproblems. Okay, let me explain this more simply. So far we worked with the bubble sort and selection sort, and what we did there is that we are making comparison on an array element which is its adjacent element in some iteration. So in that case we are trying to solve the problem in one go and using iterative approach. Okay, but the divide and conquer approach is different. Okay, here we first need to break the original list or original problem into multiple smaller parts. Okay, so this step is known as divide. Okay, for example, let's say we have an array of 100 distinct integers arranged in some random order, and we want to sort that array using divide and conquer approach. So first we will divide the array into two parts or two arrays with 50 elements in each array. Okay, then we take the first array of 50 element and divide this array further in two parts, and then we repeat this process unless you have two array of one elements in each. I mean, we reach to the base case. Okay, and once you reach at this step, I mean, you have one element in each array. Now you need to make comparison in both elements, and then based on the comparison result, arrange the elements on their correct position. Okay, so at this point your one sub problem has been solved, and then you need to solve all of your sub problems in similar fashion. And once all the sub problems have been solved, you can concur or merge the solution to each sub problem, and finally you will get the final solution. Okay, so here are the three steps. First is divide. Okay, that is break the main problem into smaller independent sub problems of the same type, and then conquer. So in this phase, what we need to do, we need to solve each sub problem recursively. If sub problem is small enough, solve it directly. Okay, and then the third step, which is combine or concur. Okay, so combine the solution of the sub problem to form the solution of the original problem. Okay, so one can say that we need to do everything in recursive manner in divide and conquer approach. So you can say that divide and conquer is the recursive in nature. Okay, and there are various examples of widely used algorithms which use divide and conquer approach, such as merge sort, quick sort, binary sort, matrix multiplication, which is Stressen's algorithm, and so on. Okay, there are many more solutions as well. Okay, and we will discuss all these algorithms that I mentioned here, like merge sort, quick sort, binary search, and matrix multiplication, and we will implement all these algorithms using Ruby. Okay, and the main advantage of divide and conquer approach is that it provides the efficiency in solving the larger problem, as it's first break the larger problem into multiple sub problems and then solve them recursively. And solving a smaller problem is quite faster and simpler rather than solving the entire problem at once. Okay, or in a single go. Okay, so however, sometimes the divide and conquer implementation might be complex, but with better understanding of it, this can be overcome. Okay, so now let me show you some example of it. Okay, so here you can see that this is an array. Okay, and we will sort it using some uh, divide and conquer approach. Okay, so let's say this is for an example for quicksort. We will discuss in the next lecture. So in quicksort, we decide a pivot element, and based upon that pivot element we split the array into two parts. So here you can see at the first step we choose the pivot as 10, and all the elements which are right to the pivot are considered as the smaller element than that, and right elements are larger than the pivot elements. Okay, and then in the next step you can see that we are further choosing pivot from 3 to 9. Okay, and hence we are doing it from next array as well. Okay, so this is the recursive process, and we need to perform it, we need to do it unless and until we have all the subproblems solved. And once we have solution for all the subproblems, what we do, we combine the result and produce the sorted array. Okay, so this is just a basic idea that how we can sort a list or an array using divide and conquer. Okay, however, divide and conquer also support two different sorting techniques. Okay, I mean, you can do in place sorting or you can do not in place sorting as well. For example, quick sort is an in place sorting technique and the merge sort is a not in place sorting technique, whereas binary search is a in place searching technique. Okay, so what you can do, that you can do something using divide and conquer. Okay, so that's all about the theoretical introduction of the divide and conquer algorithms. I hope you found this helpful, and we will meet into the next lecture with general introduction of quicksort. Okay, so thanks for watching this, and we will meet into the next lecture. Till then, tata, goodbye, take care, and stay safe.